Hello everyone, welcome back to our channel. So Shomu sir, what are we discussing today?
A very nice question, actually, Arshal. So this actually utilizes a basic idea of time speed distance, of course, but I would say primarily an idea of Pythagoras theorem. So it's a right angle triangle based idea. That would be the main context. I mean, although the question is looking for speed and stuff, but then the main idea that we're going to utilize to solve the and calculate the actual value that we're looking for, that would be based on the Pythagoras theorem. So let's jump into the question.
Yeah.
We have two ships which is meeting mid-ocean fine, and then one ship goes south and the other ship goes west. So at this point itself, we're good with visualization. One ship is going south, the other going west. So they're moving a 90-degree angle, right? To I mean, from the starting point, something like that, right? The direction of travel is 90 degree to each other, isn't it? Both traveling at constant speed, so fair. 2 hours later, they are 60 kilometers apart. So 2 hours later, the distance between the two ships is 60 kilometers. Now, it doesn't mean that the sum of the distances is 60 kilometers. So the sum of the distances will be different, right? One traveling west, another traveling south. When we are talking about they're 60 kilometers apart, that will be basically the straight line connecting the 2 points wherever they are, right? That will be 60 kilometers. If you imagine a right angle triangle, the legs being the direction of travel, then whatever is the hypotenuse is basically the distance between the two, right? So we 2 hours later, they're 60 kilometers apart, fair. If the speed of one of the ship is 6 kilometers per hour more than the other ones, we don't know the speeds individually. We don't even know the ratio of the speeds. Then the speed in kilometer per hour for the slower ship. Now, in the context, we are looking for speed in kilometer per hour, right? And this information that is provided is 2 hours later, they're 60 kilometers apart, right? Now, if you understand the basic idea of similarity, one thing that should be pretty easy understandable without drawing this. So I'm just going to draw this once and explain it. Just let me make it as close to 90 as I can. So suppose this is the scenario after, this is the scenario after 2 hours. At 1 hour, what should be the idea? So this ship must have traveled exactly half of this distance, and this ship must have traveled exactly half of this distance, right? So this hypotenuse, that is the distance between the two ships, should have been half of what it is after 2 hours.
Right, correct.
Okay, so this similarity based idea should happen very intuitively if you have a basic understanding of similarity. That is, I mean, obviously, if they are traveling with constant speeds and all. So if in 2 hours, the distance between them is 60 kilometers, and directionally speaking, nothing has changed in this 2 hours. It has been a constant motion. So speed is not changing, direction of travel is not changing within these 2 hours. So effectively, in 1 hour, it should be 30 kilometers. That should be very intuitive by nature, isn't it? So what I'm going to do is just forget about this as of now. So just let us consider this is the scenario after 1 hour. So after 1 hour, the distance between these two ships should be 30 kilometers.
Right.
Now, let us say the faster ship. So let's say, I don't care which is faster, which is slower here. So by the way, if this is given, then I'll use it accordingly. It is not given, right? So I'll just randomly assume one of them to be faster and the other to be slower. It really doesn't make any difference. So whichever is the faster ship, let us assume its speed to be f kilometer per hour. So f for faster, something like that. I'll use capital F. So in 1 hour, it must have covered f kilometers.
Yeah.
And the slower ship is suppose s kilometer per hour, s for slower. So in 1 hour, it must have traveled s kilometers, right?
Right.
Now there are two ways to solve this problem. You can, I mean, I'm not going to use these variables, by the way. I'm just going to use Pythagorean triplets. If you want to use variables, then what you do is you consider the slower, whichever is required. You are looking for slower one. So you consider this to be x, this to be x plus 6, and this is 30, right? So if this is 6 kilometers per hour more in 1 hour, this faster one must have traveled 6 kilometers more than the slower one, right? So if this is x kilometer, this should be x plus 6 kilometers, and then apply Pythagoras and you get the answer. What I'm going to do is I'm just going to use some triplet idea. So notice that, of course, the difference between f and 6, sorry, f and s should be 6, right? So the difference between this leg and this leg is 6.
Right.
And the hypotenuse is 30, right?
Right.
Now, what is the ratio of 6 and 30? That is 1:5.
1:5. Right.
So basically understand what happened. So the difference between the two legs of the right angle triangle and the hypotenuse are in the ratio 1:5.
Right.
So if we test some Pythagorean triplets, if you're aware of Pythagorean triplets, so 3, 4, 5 is a very basic one, right? See, 3, 4, 5 itself will satisfy because 3 and 4 has a difference of 1, right?
Okay.
And 1 and the hypotenuse 5. So 1:5, that is what we have here, right?
Oh, nice.
And the thing about Pythagorean triplet is a very specific type of ratio will be satisfied by only one type of Pythagorean triplet. So if you take, just for an example, if you take any other Pythagorean triplet, so suppose 5, 12, 13. So 5, 12, 13, the difference is 7 and this is 13. 7:13 is not as good as 1:5, right?
Correct.
If you take 8, 15, 17, for example, so the difference is 7 and this is 17. 7:17 is not 1:5. So a very specific type of ratio, whatever that specific type of ratio is. So depending on the data that we have. So in this case, the data that we have is the difference between the two legs and the hypotenuse. So get the ratio of that. Whatever constant values you can determine, right? You cannot get a ratio between a variable and a value. That will not give you a specific ratio, right? For example, in this case, I cannot get a ratio between f and 30. That doesn't make sense. I don't have the value of f, isn't it?
Right.
But because I have the difference between f and s and I have 30, I can determine the ratio. So that ratio will be satisfied by only one Pythagorean triplet. If it doesn't work, then just use Pythagoras theorem, and that's it. So now the advantage is we can directly use this. So because of hypotenuse is corresponding to 5, so this 30 is nothing but 5 into 6, right?
Right.
The other two should be corresponding to 3 into 6 and 4 into 6. Obviously, the smaller one will be 3 into 6. The bigger one will be 4 into 6. But we are concerned with the smaller one because we're looking for the speed of the slower ship. So 3 into 6 is 18 kilometers, meaning the slower ship has covered 18 kilometers in 1 hour. So that is our answer.
Nice. So this was actually, I won't say an interesting question, but the way you explained the solution that you provided, that was pretty interesting.
Yeah, I mean, question was also interesting because it uses the idea of Pythagoras. I mean, usually when it comes to time, speed, and distance problems, you will have a very straight cut kind of ratio based or scenario based resolution, right? This will just throw the students off a little bit by that geometrical orientation. If you're not comfortable with geometry, you might be a little itchy to solve this. But then, yes, I mean, as I mentioned in our lessons and stuff also, I mean, when it comes to Pythagorean triplets, the idea behind Pythagorean triplets is always to simplify calculation. That's it. So
Right.
I mean, there is no question which you can only solve using Pythagorean triplets and not by Pythagoras theorem, because Pythagorean triplets come from the Pythagoras theorem, right? So it's purely from calculation point of view, it will save a bit of time. So if you know how to, utilize Pythagorean triplets easily, then obviously you can utilize it in the questions. I mean, people usually think that Pythagorean triplets is only got to do with just multiples and stuff like that. I mean, usually they don't use this difference and stuff while using the Pythagorean triplets, but they can. So even sum and all, I mean, a lot of questions. I mean, for example, if I have something like R, or rather something like this. I mean, this, if somebody can relate, if they have done a question like this, is a very famous type of question. So if you have something like R minus 6, R minus 12, all the three are in variable form, right? All the sides. Now, if I have to solve this, what I'm observing is this R minus 6 and R minus 12, that is in AP, right?
Right.
And there is only one Pythagorean triplet, which is in AP, that is 3, 4, 5.
3, 4, 5, correct.
This should be 3, 4, 5 triplet, but some multiple of it, because the difference is in difference is 6, right? The common difference of this AP. R minus 6.
Right, correct.
And in 3, 4, 5, the common difference is 1, isn't it?
Right.
So if I have to get it to 6, I need to multiply 3, 4, and 5 by 6, right?
Right.
So this R will be 5 into 6, R minus 12 and R minus 6. R minus 12 is the smaller one, of course. R minus 6 minus 6 is R minus 12. So this will be 4 into 6 and this will be 3 into 6. I mean, you don't have to do all of this because R determined R minus 6, R minus 12, anyhow you can determine. But yeah. So Pythagorean triplet, the idea is always to save calculation, nothing more.
Right.
I mean, in this question, I mean, instead of doing, I mean, even in this question, so for example, if you would have gone with, let's say x plus 6 and this 30. So what would you have typically done? X square plus x plus 6 whole square is equal to 30 square, right?
Correct.
So you would have done x square plus x square, that is 2x square. No way to avoid this quadratic, right? Because if it is a minus thing, then the x square cancels off. But if it is, the variable is on the legs, then that will remain. We'll carry forward to the final equation, right? And then you have 12x or whatever. plus 12x, and then you're 36 and 30 square. So I'm getting the picture. It's becoming a little calculative by nature, right? 860 something. So then you solve this and figure out the answer. I mean, it's not undoable, but it will take a little bit more time to do this.
So that's why I pointed this, that the solution was pretty damn interesting. I mean, going through this conventional way of equations, that would typically take quite a few minutes more than what we did over here.
Yeah, agreed. And that is why Pythagorean interprets come into play for this question.
Thank you so much, sir, for this wonderful solution.
Yeah, thank you, Arshad. Thank you, everybody.
Thanks everyone for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.